All right, our next section is on inverse functions and relations. And let's define the inverse of a relation first. The inverse of a relation is the set of ordered pairs obtained by interchanging the x and y values of each ordered pair. So literally, we're just switching the x's and y's. So here's our example. This is my original relation here, and this is going to be the inverse of it. I just switch the x and y. So negative 1, 1, 1, 2, 3, 3. Of course, when we switch them, they actually stay the same since they were equal to begin with. All right, so let's go ahead and graph these two. 0, negative 3. 1, negative 1, 2, 1, and 3, 3. There we go. Okay, and now we're going to graph the inverse, and I'm just going to do a different kind of symbol here. I'll just kind of do a little star thing. Negative 1, 1, right there. 1, 2, and 3, 3. They meet right there. Okay, so this is going to be an important visual for you to kind of think about. We're not quite there yet. Okay, so we have the ordered pairs, and then we plotted them. Okay, the inverse of a function is very handy when we're doing conversions. So here you see that if we're going from Celsius to Fahrenheit, or the other way, we have these inverse functions. All right, so the first problem was to find the inverse of a relation given a set of ordered pairs. Now we're going to find the inverse of a function given an equation. Okay, and here I call it y. I maybe should have called it f of x. The first step to finding an inverse given an equation is to change f of x to y. So there our first step is done for us. The next thing we do is we actually switch the x and y, so it becomes x equals 2y plus 2. Now we solve for y, so I'm going to subtract 2 from both sides. Now I'm going to divide everything by 2. And we solve for y, and so my new equation is y equals 1/2 x minus 1. And that's the inverse function, so I'm going to put a little superscript there of negative 1. Okay? And here I say if the original function is given in function notation, first change it to a y value. So if we started with function notation, we would have ended with this notation for our inverse. Okay, the inverse of a function f of x is f negative 1 of x. And the inverse may or may not, we don't know, be a function. Okay, now there's a built-in check. When we take a function and we find its inverse, we can check to see if we did all this work right by using the composite function, and that's why we just learned the composite function. If I take a function and its inverse, and I take the composition of those two functions, I should get x. So I'm actually going to use this one up here, not the one that says practice. My original function was 2x plus 2. I'm going to take the composite of that function with the inverse. That's f of 1/2 x minus 1. So everywhere I see an x in f of x, I will replace it with this function, and I'll get 2 times 1/2 x minus 1. I have to bring down this plus 2. Distribute. 2 times 1/2 is just 1. We don't need to write that. Minus 2 plus 2 equals x. This is my check. If the composite of a function and its inverse equals x, then I did it correctly. Okay. So let's go ahead and try this. Let's find the inverse of this function first. I'm going to change f of x to y. I'm going to interchange my x and y. I'm going to solve for y. Subtract 6 from both sides. Let's bring it up here. Now I'm going to multiply both sides by the reciprocal, negative 4/3. Okay? Let me just do that margin work here. Negative 3/4 times negative 4/3. Negative times a negative is a positive. 1, 1. That just equals 1, so that'll get rid of my fraction here, so that I'll solve for y. So again, I'm going to multiply this by negative 4/3. Whatever I do to one side, negative 4/3, I must do to the other side, every term on that side. So I'm going to distribute negative 4/3 x minus negative 4/3 times 6. Well, let's see how we should do this. Negative 4/3 times 6 equals y. And it's a negative times a negative. It's going to be a positive. 3 goes into 3 once, 3 goes into 6 twice. So it's going to be negative 4/3 x. Negative times a negative plus 8 equals y. Okay. And now the last thing I'm going to do is I'm going to check that. And I'm going to use this space down here. Sorry about that. So I'm going to find, oh, and I'm sorry, the last thing is f inverse of x equals negative 4/3 x plus 8. There's my answer. And now let's check to see if we did it right. I'm going to find f of f negative 1 x. Okay? My original equation, and where I see x, I'm going to substitute that. Negative 3/4 times negative 4/3 x plus 8 plus 6. Distribute this. Negative 3/4 times 4/3, negative 4/3 is x, and negative 3/4 times 8 is going to be negative 6. Okay? Negative 3/4 times 8, the 4 and the 8 would cancel out. 4 goes into 4 once, 4 goes into 8 twice, and then 2 times 3 would be 6. Plus 6 equals x. Check. It worked. Okay? And now the definition of what an inverse relationship is. Two relations are inverse relations if and only if. IFF is read if and only if one relation contains the element BA whenever the other relation contains the element AB. Everything, no matter what A is, if I have an A and I have a B, I'll have an inverse relationship if that is switched for every A and B in the relation.